Welcome back, folks. Today, we're tackling a hot topic. We'll experiment with Copilot to build CI/CD pipelines for both Gitlab and Bitbucket. I've set up the perfect development environment for a pipeline. We're working with a MERN stack web app, so we've got a React client, an Express server, and a MongoDB database. Plus, there's a playwright test to check that everything integrates smoothly. If you want to try this setup yourself, it's the MERN stack example from MongoDB's website. Here's what the app looks like when it's up and running: a simple employee management system with adding, editing, and deleting employees. Here's the shell script we want to execute. We'll build upon this by adding other stages like linting, security scanning, and deployment. I'm using GitHub Copilot as my assistant, but you can use your favorite. I've tried Amazon Q and Codium too, and they're solid options. Alright, let's start simple. We'll start with Gitlab, then later convert it for Bitbucket. The generated pipeline looks good, but I'd rather keep it in one stage. Separating the npm install commands from the execution stage doesn't offer much benefit, and I don't believe CI/CD platforms recommend it. Alright, now we need to add MongoDB support to the pipeline. Looks good. This would probably work, but let's improve it by adding linting and a security scan. Now I can't recall if semgrep needs an app token. I think it does, so let's add that just in case. You can grab a token by signing up on their website and navigating to Settings and then Tokens. Once you have it, add it to your GitLab repository settings. That semgrep command might work, but I prefer using the semgrep CI with the code parameter. It performs the SAST code scan specifically, skipping dependency scans. When you're building a pipeline with AI, you probably already know how to run everything locally. If the AI suggests different commands, just swap in your own, the ones you know work. The semgrep image seems outdated, so let's update that too. Moving on to deployment. We're using AWS CodeDeploy to deploy to an EC2 instance. The assistant's starting point is good, but some missing pieces need attention. We need to configure AWS CLI by specifying the region and access keys for your AWS account. You can find those in the AWS console under your profile and security credentials. There are various ways to handle AWS deployments, but in their examples, you zip the app with an appspec.yml file and upload it to an S3 bucket, then pass the bucket as a parameter in the deployment command. Since I'm unsure if the Python image includes the zip executable, let's install it just to be safe. Let's name the environment production. So GitLab recognizes it as a production tier. That makes it trackable and lets us roll back to previous versions if needed. I'm also adding a when manual rule, so it only runs when I trigger it by clicking a run button. You'll see that in action when we launch the pipeline. We're almost there, but a couple of manual tweaks are in order. This line appears to have an extra period. Normally, you'd lint the whole environment, but since this is a demo, I'll lint just the client folder, since that's where the lint config is. I want to set Allow Failure for linting and security scans, preventing them from halting the pipeline on issues. I almost forgot logs and test results. We want these saved as artifacts for potential debugging. I'll set them to expire in a week. These kinds of small details are often easier to adjust manually. My code resides in the main branch, not master. As you can see, there are quite a few details to iron out, but a code assistant can definitely be a helpful starting point. Now, we need to configure the deployment parameters. I've already created an S3 bucket and an AWS code deploy application. It's a quick process. Let's plug in the details I created. One final tweak, defining a default image for the pipeline. We'll use the latest node image as the default unless specified in a stage. Time to push the file to GitLab and kick off the pipeline. First up is linting. The linter flags some issues in the code, but remember, we set it to allow failure, so the pipeline continues running. The next stage is the security scan. Let's see if it can find any security issues. The job succeeded, and the scan successfully identifies 7 non-blocking code vulnerabilities. And our tests passed, which means the app was set up, the database was live, and everything else worked. Since we set the deployment stage to manual, the pipeline pauses here. Let's click the deploy button and see if the deployment works. The job succeeded. If we check the AWS console, we can see code deploy installing the app on our EC2 instance. Before moving on to the conversion for Bitbucket, let's revise the whole process so far. Start by prompting the AI to create a pipeline based on your local script. Then, ask it to add any required services. Next, have the AI generate the security scan and linting stages. Finally, add a deployment stage to complete the pipeline. After these steps, remember to review all commands and parameters for accuracy. Now let's take it one step further and convert this pipeline for Bitbucket. This looks promising. I'll copy it to a file, push it to Gitlab, and import the Gitlab repository to Bitbucket. After grabbing the repository URL, we head to bitbucket.org to import it. We'll need to add the token and secret key variables to the repository settings. Looks like we also need to enable pipelines for this repo, so I'll do that now. Then we'll add the AWS Secret Access Key, AWS Access Key ID, and semgrep app token. Now we're set to run the pipeline for the first time. The pipeline failed and stopped at the linting stage because of code issues. Unfortunately, Bitbucket doesn't have an allow failure option yet, so here's my brutal but beautiful workaround. I'll just comment out the linter line. Another way would be to use a shell script in the after step that exits 0 when there are errors. But for now, this quick fix will do. The SAST scan failed too. Turns out there's an extra period in the command. Looks like that error carried over from the assistant's code. After fixing it, the security scan runs fine. Then we hit a topology is closed error in the test stage. This error is due to a key difference between Gitlab and Bitbucket. In Gitlab, a service address matches the image name, while in Bitbucket it's set to localhost. So MongoDB service needs Mongo and port in Gitlab, but localhost and port in Bitbucket. There it is, the test step passed. We only needed a couple of tweaks for Bitbucket, handling the allow failure option differently, and changing service addresses to localhost. Now let's trigger the deployment stage. Deployment failed, this one's on me. It seems when I manually updated a piece of code, the assistant didn't pick up on the change and used its own previous code. Let's fast forward to save some time. And now deployment works. That wraps up our tutorial. I've shown you how to create a CI/CD pipeline with a code assistant. If you enjoyed this video, share it with your fellow coders. Thanks for joining me on this exploration.